All right, guys, so let's pick up from here. So again, I labeled the x1, y1, x2, y2. Again, start with the formula. The more you write it, the more that it will stay in your long-term memory. And also, sorry for all of the breathing you hear me doing in the video. Y2 is 6 minus y1 is -1. Again, I cannot stress that there is a subtraction symbol between your y2 and y1. And if the term behind the negative has a negative, you have to write that in because this is, right, -1, which is your y1 term. So that becomes a plus plus. And then you have x2, which is 5 minus x1. Okay, they were both positive. So you have a 7 over 2. Okay. And so essentially what's happening here is you're going 7 units, and we'll talk about that. Again, this is my delta y. This is delta x. So again, the change, if I was to plot those 2 points, which I'll do it super quick, there are 7 jumps going upward. There are 2 moving to the right. That's the address. Move up 7, and I said up because it's a positive number. The 2 is positive, so I'm going to go to the right. Remember, x values go left or right, like the number line. Y values go up or down. So if we quickly just sketch this to the side super fast, 3, -1. So I'm going to call this 3, -1, about right here. And then I have 5, 6. So I'm going to go a little bit further over to the x. Say about maybe right here is 5. And then 6, positive, would be, let's say, up here. Again, these are not drawn to scale in any way, shape, or form. Notice that as I move from the left over to the right, do you see how I'm down here? And then as I'm going, the next point is upward. So that means this has a positive slope and it's increasing. And I'll get into that in just a second. So here's my line. And we'll start talking about that. If you're given 2 points, give the equation. Okay. So, but for right now, we're just focusing on figuring out how do we get from here to here. So according to this math I did, we're going to go 7 jumps upward in the y direction and 2 in the x direction. And let me change colors. So imagine we're at -1 here. How many jumps is it to go from here up there to find out your change in your y? Well, basically the answer is 7 because you jump up 1 to get to 0, right? And then that's 1 jump, and then you have 6 jumps to get to here. So 6 plus 1, see, that's that 7. And then you're at 3 for the x, and you're going to 5 horizontally. So that's 3, 4, 5. That's 2 jumps. So notice that's the address. If I live here and I'm trying to get to my grandma's house, like I tried to give the example, like your family, you're all related, right? You all live on that line, your points. How do I get from here to here? Well, I would go up, 7 blocks down and then turn and go 2 or 3 houses or blocks up, okay, on that street, if you want to think of it that way. All right, so again we had a positive value. So now that I've gone over that, let me do one more that has decimals real quick, and then I'm going to move on to the next concept. All right, so here we got -3.15 or 1500ths, and then we have 8 and 2500ths. That's 1 point. Then another one is at 6 and 8500ths and -4 and 2500ths. Here we go. All right, so we're going to label this carefully. x1, y1, x2, y2. All right, so if our slope, m equals y2 minus y1 over. All right, so for this one, you have to be very careful because you have decimal numbers, right? And again, when we're doing addition and subtraction, we have to line up our decimals and be careful with our arithmetic. So y2 is -4 and 2500ths minus y1 is 8 and 2500ths. x2 is 6 and 8500ths minus, because x1's negative, 3 and 1500. So that minus becomes a plus plus, and I'm going to drop down here. All right, so now remember I told you about when you have a minus, okay, you can change it to a plus, bump back the negative, and so essentially we're going to end up adding those two. So if we have $4.25 and $8.25, we would have $12.50. So just think about money, okay? So we have a negative though, 12.50. Okay. And then here we're going to add those. So let's be really careful on that. So 5 plus 5 is 10. So I'm going to put a 0. In my mind, I'm telling myself to carry a 1. So that's 8, 9, 10. So I'm going to have another 0. Then, you know, those two and those two are lined up together. So now I have the decimal coming. And then I have 3 plus 6, which is 9. And that's it. Okay. So this is the address. And it's going to be a little strange to some of us because, again, you have that 0.5. Okay. So essentially, if this is my delta y, I'm basically saying, and there's a negative on it, I'm going to go down 12 jumps and then a half of a jump. So I'll be between some numbers. And then for my delta x, I'm going to go 9 points over or jumps to the right. So if I was just sketching this, and again, we're just going to save some time, is I'm going to approximate this. So this is negative 3.15. So let's say that's about, you know, right there. And then I'm 8.25. So way up here somewhere, let's just call this 8 and this is 9. So about right there, close to the 8. About right there. And then for the 6.85, so I'm over here now. Here's 6 and 7. And I'm about 6.85. So pretty close to 7, about right there. I just put a little mark so I know I'm there. And then negative 4.25. So if I come down, let's call this negative 3, negative 4, negative 5. And so I would be kind of here and just a hair past that negative 4. Okay. And notice that, again, when I move from left to right, there's a point here, and then it's this next point is here. So it has a downward slope. Sorry, missed the whole dot. Okay, so the m is negative. So I just want to show these side by side. So see how this one's increasing? It's going up, rising to the right. This has a positive slope. That was the 7/2. And then here it's going down to the right, so the m is negative. Okay, so again, and the math shows that, right? So again, if I was going and I want to go from here to here, remember we moved from left to right. So I would go for the y direction, and I'm going to show this again too. So if I put a nice horizontal line, which would be my y value, the y value for this point is 8.25. And if I put a nice horizontal line going through here, right? This is that negative 4.25. So how many jumps is it from there to there? Again, it's 12.5 is what it's saying. And I would go down because I want to go here and I want to come down and get in that same, you know, area, or not area, I'm sorry, but I want to be in that same plane here. So from there to there in the change in the y, that's the negative 12.5 jumps. And you could really take your time if you had a coordinate grid of graph paper and you plotted it perfectly, you can count all the jumps, okay? But at least I know, hey, from here down to here is basically 8.25, right? Because we would be at 0. And then I want to add an extra 4, right? So then and you have to be careful because you have those 0.25s. But again, the math works out. I can explain it, but I don't want to be confusing right now. So from here, we want to talk about what's happening essentially horizontally now that I've gone down. So if I draw a vertical line going through this point like this and like this, and then I do a vertical line going through here, then the question becomes, well, now that I've jumped down here, how much do I go across this way? And basically that would be the 9 jumps. So that's the answer to that one. All right. Okay, so the next thing that I want to talk about real quick is I've been talking about how the positive slope, I've talked about negative slopes and how they go up or they go down. So one thing I want to show you real quick is I'm going to draw out how slopes can actually be. All right, we're back. I'm using the bottom of a piece of paper so that information above is from something else. Okay, so here are the different ways that we can have different slopes. So you can have it positive, which means it's going, like I said, up to the right, so it's increasing. So your m is positive. Some positive value, can be a fraction, whole number, doesn't matter, a decimal. And then if it's negative, it's going down to the right, so your m will have a negative value. And then of course you can also have m equals 0, okay, which means that it's a horizontal line. And I'm sorry for this little kind of typo writing there, but if you have a 0, let me just rewrite this. If you have a 0 in the numerator and then some kind of value at the bottom, then m will equal 0, and that's a horizontal line. And it's an undefined line, okay, if you have 0 in the denominator. So very important that you understand that vertical, the slopes are undefined, and then if they're horizontal, m is equal to 0. So let's get into a couple of those, all right? So here is an example of those kind of situations. So let's just say for a moment they give us a point and 2 points, and we have 5 comma 6, and the other one is 5 comma negative 2. So as you see, you'll notice that as you're labeling this, right, you have your x1, y1, x2, y2. So if the x coordinates are the same, watch how the math will work, and we'll figure out, is it, again, it's not a positive or a negative slope. You'll see that, you know, it's going to be one of these two because two of our values are the same. Okay, so what happens if our x's are the same? Is it m equals 0 or m is undefined? So if I use my formula, y2 minus y1 over x2 minus x1, so my y2 value is negative 2 minus 6, and then I have 5 minus 5, right? So notice the x's are in the denominator, so we get 0 down here, and then we're going to change this to a plus bump back, and this is a negative 8. So this is undefined, okay? So m is undefined. Sorry about that, guys. Undefined, and this would be a vertical line. Now I'm going to graph it for you so you can see that, okay? So if we were to take a sketch here, and I was graphing 5 comma negative 2, so if I have 5 negative 2, so let's say 5 is here for our x, negative 2 let's say is down here, so here's a point. And then we have 5 comma 6. So see, we would go 5 and go up 6. So let's just say 6 is here. So as you can see how those points are right on top of each other, like so. See, you get a vertical line. Therefore, m is undefined. And it's undefined because you can never have 0 go into any number. 0 can't divide into anyone because he has no value. All right, so that would be an example again of an undefined line. So anytime you have a vertical line, m is undefined. Just remember that, and then I'll do a horizontal one, okay? For a horizontal one, let me see if I have some space here. So for a horizontal one, imagine they give us the points 3 comma 8 and negative 5 comma 8. So in this case, what you notice for these 2 points is that our y values are the same, okay? So again, we're going to do m equals y2 minus y1 over x2 minus x1. And so as you can see, my y2, I'm going to do 8 minus 8 over negative 5, because that's my negative 5 minus 3, okay? So I'm going to change to a plus, bump back, and notice what you get is 0 in the numerator and then a negative 8 down here. So because the 0 is here and we have a negative 8 in the denominator, basically m would equal 0, okay? So this would be a horizontal line, and let's graph it real quick so you can see it. So again, if we are at 3 comma 8, if we were at 3 comma 8, that means we're at the 3 let's say 8 is, somewhere up here. And we were plotting -5, which let's say -5 is here, and then 8's there. So you notice that when you connect these two, sorry, go ahead, Alaric. This would be a horizontal line. Okay, so that shows that the slope is 0. All right, and that takes care of that. All right, I apologize about that. It's taking me some time to get this done. All right, so let's talk now, and that's all I want to mention for a moment. So again, if you're given, let me just show that one more time. If you're given 2 points and the x coordinates are the same, then it will always be a vertical line. Okay, if you are given 2 coordinates and the y values are the same, it will be horizontal. And when it's horizontal, m equals 0, and when it's vertical, m is undefined. Okay, all right, so let's move into the last little part of section 4.2 and make sure that you're doing your connect math. I think I'm just going to go to a fresh sheet of paper. Okay, so the last thing I want to talk about, we've talked about horizontal lines, we've talked about vertical lines, we've also talked about positive lines and negative. So that part again is the part that I showed you that has to do with those 4 right here. Okay, so now let's talk about parallel and perpendicular, which brings me to not just one line, let's look at 2 lines. So the next little part you need to put for your notes is let's put parallel and perpendicular lines. Okay, all right, and the way that looks, parallel and perpendicular lines, is parallel, of course, they run, you see, just like that. They run along each other. They never intersect. Perpendicular, however, you can have one like this. You have one like that. It forms a 90-degree angle. You don't really need to know that unless you're doing geometry. But the fact that they intersect, they have a common point of intersection, which we'll get into that. All right, so let's move on. So parallel, again, they do not intersect. So let's put that. Do not intersect. They never will. And this one, they will have one common solution or one point of intersection. Okay, one common solution. But the other thing I want to talk about is, let's say this is line 1. It has a slope 1. This has a slope m2. And so, yes, you see they don't intersect, but their slopes are equal and congruent. So m1 is equal to m2 if they're parallel. If they intersect and they have one common point of solution, okay, one thing you need to know about their slopes, again, this is m1, and let's say this one that's vertical is m2. They have opposite reciprocals. This is going to look a little strange. So you got m1, and then you got -1 over m2. So when I say opposite reciprocals, I mean that they have opposite signs, like this one is positive, this one is negative. And reciprocals, okay, basically mean this, that whatever this number is, it's basically going to be negative, and it's going to be 1 over whatever the m1 is. So a better way to write this, I think, is to put 1 over m1. And when 1 is divided by m1, it's going to basically be flipped. So let me tell you what I mean. What I mean is, let's say the slope was like 5 for our m1. So the slope of m2, which is all of this stuff here, is m2. It's going to be opposite reciprocal. So it's going to be -1 over 5. Okay, so this would be m2 and this one would be m1. So it's opposite and then reciprocated, which means we took the 5 over 1 and then we flipped it. It becomes 1 over 5 and negative. All right, so let's get into some examples with this. Let me zoom in. Okay, so now what it says on page 215 is, it says, suppose that you have a line that has a slope of -6. So let's say we have some line and m is equal to, like they just said, -6. What they're wanting us to do is, they say, find the slope of a line that is parallel to this slope. Well, if it's parallel, it's the same. So we're going to say m, we'll call that m1, m2 is also equal to -6, and we'll say basically because they're parallel lines. right? B says, find the slope of a line that is perpendicular to this given slope here. So the M2 for the perpendicular line is going to be not negative, but a positive, and it's not going to be 6 over 1, but 1 over 6. This one is the perpendicular. Okay? It's just that simple. Flip it, and then change the sign. Okay? All right, so let's do another one. What if they gave me, so we'll say given M1 equals 5 over 3. And again, for part A, they want the parallel to that. So we would say, well, the slope of the second line, M2, is the same thing for them to be parallel. So the slope of the second line is the same, 5 over 3, because they're parallel. If I wanted, again, the perpendicular line that intersects with M1, then the slope of that second line must be not positive, but a negative, and not 5 over 3, flip it. So 3 over 5 is the perpendicular. All right, so I hope that makes sense. Okay? And let's move on. So the last thing that we're going to talk about, and I'm going to try to squeeze this in at the bottom, sorry about the purple, is we're on the last page of page 216, and it says determine if lines are parallel or perpendicular. So here's what they'll do. Ready? They'll give you line 1, okay? And they're going to give you 2 points that are on line 1. They're going to give you 2 points that are on line 1, and here are 2 points on that same line. So remember, you got these 2 points, okay? And line 2, here's 2 points off of this line, -3, 1, and 1, 0. Sorry about that, guys. So what we're going to have to do is, because we have these 2 points, what can we do? We can calculate the slope, right? So we'll do our, y2 minus y1 over x2 minus x1, get this m slope for line 1, and then we'll get this slope for line 2, and then we'll figure out, are they parallel or perpendicular? That's how you determine. So here's the math, okay? So I'm going to write the slope formula just up here. And again, you got to do it 2 times because you got 2 lines, okay? So again, here's point 1. I'm labeling it x1, y1. Here's x2 and y2. So here's my math. Ready? y2, so I'm going to do 1 minus y1, -7, over, and I'm doing x2 minus x1. And when I was growing up doing this in school, all I did is I would just say the formula aloud, say the numbers, say the, x1, x2, and then I memorized the formula, and I would just do a lot of practice. So far we've figured out that M1 is equal to +4. All right, let's go to line 2, and I'm just going to box that for a moment so I can just see where my answer is. Okay, now at the bottom here, we're going to do it again. y2 minus y1, so we're going to do 0 minus 1 over 1 minus -3, 1 minus -3. Okay, and that minus becomes a plus. So see, I'm going to get a 4 down here, and then where that negative is, let's change it to a positive, bump it back. This will be a -1. And so far we have found out that M2 is equal to -1/4, and I'm going to box that. So now let's look at them side by side. Well, he's positive, check. He's negative, so maybe they're perpendicular. And then, oh yeah, if that's 4 over 1, and if I were to flip it, do the reciprocal, then it's right there, 1 over 4. So these are what? Okay, so those are perpendicular lines. Okay, so let's do another one of these. Okay. All right, so again, this is the last little thing here. Let's find another one where they give us 2 lines, and we got to figure out if they're parallel, perpendicular. So what if line 1 has the following 2 points? What if we have 2, 4, and another point on that line is -1, -2, and line 2 is 1 comma 7, and then we have 0 comma 5. And I'm also going to sketch these, and we can also look at them as well to see if they intersect or if they are parallel. But first, let's do our math. Okay, so we're going to find M1, and we got to find M2. So for M1, again, I'm not going to write the formula because I think we should have it down here. But again, we're doing y2 minus y1. So I'm going to do negative 2. That's what I mean by I say the numbers. Negative 2 minus 4 is in the numerator. I'm doing x2 minus x1, so negative 1 minus 2. And notice I'm going to change to a plus, bump back, change to a plus, bump back. So this is negative 6 over negative 3, which is positive 2. So M1 is equal to 2, positive. Now for M2, we're going to do 5 minus 7 over 0 minus 1, change to a plus, bump back, change to a plus, bump back. So we get negative 2 over negative 1, which is a negative divided by negative is again a positive 2. So M2 is 2. So look at that, they're the same. So because M1 is equal to M2, then we're going to say these two lines are what? Parallel. Parallel. Okay, good deal on that. All right. Oh, real quick, if I sketch just so we can see. So if I did a sketch very quickly, and I'm going to plot 2, 4 roughly. So again, I'm going to call this 2. I'm going to call this 4. Negative 1, negative 2. Here's negative 1. Here's negative 2. And then I just carefully make a line. Okay, then I'm going to plot 1, 7. So I'm going to call this 1. I'm going to say 7 is somewhere up here. And then I do 0, 5. So I go nowhere in the x direction. So I stay at the origin. And I'm going where? 5 up. So 5 up, let's just say is right there. I'm just going to say a smidget above 4. And then look, I plot that. And notice, see, they're parallel lines. They run along each other and they will never intersect. So that's what I mean by, again, the fact that they're parallel, they never intersect, and then they have the same slope. Because if you were to try to, again, get from here to here, what would you be doing? You'd be going what? Up 2 over 1. And then from here to here. Now, it's more than 2 going up and 1 over. But the thing is, you have to realize however many jumps it is to get here and over here, it will reduce to 2 over 1. So they have the same slope. All right. So I hope that makes sense. And this video is kind of running a little long. So I think I'm going to just stop it there. And if you have any questions, let me know. Okay. And you guys have a good night.